Hi everyone, I am JULKA. Today in Geometric Progression Part 2, we'll talk about geometric means and some more problem based on GP. First example, find three geometric means between 1 and 81. Let three geometric means are G1, G2 and G3 between 1 and 81. So when we insert geometric means between numbers, it become a GP. So 1 comma G1 comma G2 comma G3 and 81 in GP. 1 is the first term, G1 is the second term, G2 is the third term, G3 is the fourth term and 81 is the fifth term. So here A equals to 1 and the fifth term is 81. Fifth term is A multiplied by R raised to the power 4. Here A is 1, so R raised to the power 4 equals to 81 and R equals to plus minus 3. If A is 1 and R is 3, then geometric means are G1 is second term which is equals to AR, G2 is third term which is AR square and G3 is the fourth term which is AR raised to the power 3. So after putting the value of A and R, we will get G1, G2, G3, 3, 9 and 27. And if A equals to 1 and R equals to minus 3, then G1 equals to, which is second term, A into R, G2 which is third term, AR square and G3 which is fourth term, AR cube. After putting the value of A and R, we will get minus 3, 9 and minus 27. So geometric means are 3, 9, 27 or minus 3, 9 and minus 27. Next example, if A raised to the power n plus 1 plus B raised to the power n plus 1 divided by A raised to the power n plus B raised to the power n is geometric mean between A and B, then find n. Geometric mean between A and B is root AB. So A raised to the power n plus 1 plus B raised to the power n plus 1 divided by A raised to the power n plus B raised to the power n equals to root AB. After cross multiplication, we will get A raised to the power n plus 1 plus B raised to the power n plus 1 equals to root AB multiplied by A raised to the power n plus B raised to the power n. And when we further simplify, we know that A raised to the power n plus 1 is A raised to the power n into A, B raised to the power n plus 1 is B raised to the power n into B. And now we will separate the terms containing A raised to the power n on the left hand side and separate terms containing B raised to the power n on the right hand side. And if we will take A raised to the power n into A to the power half common on the left hand side, we will get A raised to the power n into A raised to the power half in bracket A raised to the power half minus B raised to the power half. Similarly, when we take B raised to the power half into B raised to the power n common on the right hand side, in bracket we will get A raised to the power half minus B raised to the power half. After simplification, we will get A to the power n upon B raised to the power n equals to B raised to the power 1 by 2 upon A raised to the power 1 by 2. Or we can rewrite this way, A upon B raised to the power n equals to A upon B raised to the power minus 1 by 2. So n equals to minus 1 by 2. Next example, prove that the product of first n terms of a GP equals to AB whole raised to the power n by 2, where A is the first term and B with the last term. A1 is given A and the another term is given B. Another term is A multiplied by R raised to the power n minus 1. So A multiplied by R raised to the power n minus 1 equals to B. Now P denote product of first n terms, so which equals to A1 into A2 into A3 and so on till to nth term. So P equals to A into AR square and so on till to A R raised to the power n minus 1. So P equals to A multiplied by n times, so it is A raised to the power n and R raised to the power 1 plus 2 plus 3 till to n minus 1. The sum of first n minus 1 natural number is n minus 1 into n minus 1 plus 1 upon 2. Now in A, power divide by 2 and multiply by 2. Now if we take n by 2 common, so we have A square into R raised to the power n minus 1 whole raised to the power n by 2. A square can be written as A into A. So we have P equals to A multiplied by R raised to the power n minus 1 whole power n by 2. and a into r raised to power n minus 1 is b. So the product is ab whole raised to power n by 2. Last example. If sum of two numbers is 6 times of their geometric mean, then prove that the ratio of the two numbers 3 plus 2 root 2 ratio 3 minus 2 root 2. Let required numbers are a and b. It is given that a plus b equal to 6 times of root ab, because the sum of the two numbers is 6 times of their geometric mean. We can rewrite this a plus b equals to 3 times of 2 root ab. Now a plus b divided by 2 root ab equals to 3 upon 1. If we use componendo and dividendo both sides, we will get a plus b 2 root ab divided by a plus b minus 2 root ab equals to 3 plus 1 divided by 3 minus 1, and it is equals to root a plus b whole square divided by root a minus b whole square equals to 2. When we square root both sides, we will get root a plus root b divided by root a minus root b equals to root 2. Now using componendo dividendo again, and we will get root a plus root b plus root a minus root b divided by root a plus root b minus root a plus root b equals to root 2 plus 1 upon root 2 minus 1. Now after simplification, we will get root a by root b equals to root 2 plus 1 upon root 2 minus 1. Now squaring both sides, and we will get a upon b equals to root 2 plus 1 whole square divided by root 2 minus 1 whole square. After further simplification, we will get a upon b equals to 2 plus 1 plus 2 root 2 divided by 2 plus 1 minus 2 root 2, which equals to 3 plus 2 root 2 upon 3 minus 2 root 2. So the ratio of a and b is 3 plus 2 root 2 ratio 3 minus 2 root 2.